Section 4.3b is about inverse relations. An inverse is when you switch the coordinates in each ordered pair. By switching the coordinates, I mean switching the x and the y, and that's all you do is you flop them and you get a new ordered pair, and that's the inverse. So let's look at some examples. Here we have a table, and we have to write the inverse of this relation. To find the inverse, we take each one of these ordered pairs and we flip it. So instead of x being a 3, the x will now be the -2, and the y will be the 3. So I just rearrange those. -6, 7 becomes 7, -6. 4, 3 becomes 3, 4. And -6, 5 becomes 5, -6. Squiggly brackets show that it is a set, an inverse. Let's do the next one over here. I have a 2 paired with an 8. So the inverse would mean I'll go 8, 2. I have a 3 paired with a 7. So the inverse is 7, 3. Switch the x and y. 4 paired with a 6 makes it a 6, 4. And lastly, a 5 paired with a 7 is a 7, 5. That's how you find the inverse. This one down here, we have graphs. So let's do this point. -1, 2 means 2, -1 will be my inverse. This point is 2, 4. So I'm going to use 4, 2. This point is 1, 2, 3, 4, -1, which means -1, 4 is my inverse. And here is 3, -3, which means -3, 3 is my inverse. Now, in case you struggled to follow that, I'll label the ones in this example. 1, 2, 3, 4, -4, 1, so -4, -4 is this ordered pair, which means the inverse is the same actually, -4, -4. This one is -3, 0, so the inverse point is 0, -3. This one is 0, -3, so the inverse is -3, 0. Here we have a 2, 1, so the inverse is 1, 2. And lastly, a 2, -1, so the inverse is -1, 2. So all you do to find inverses is you take the x value, make it the y, and take the y value and make it the x.